Okay, so hello guys. This is the question we're going to be treating today. The question says we should find the current flowing through this 3 ohms resistor here, okay, using superposition theorem. And if you don't know what superposition theorem is, check the first video on superposition theorem on this channel. Then you know that the first step after watching that, you know that the first step is we'll consider the circuits with one source at a time. Okay, so let's say I want to consider the current source here. I'm going to shut down these two sources. Remember, you shut down voltage source and open up current source, which we'll see later as we go on in this video. So I'm just going to clean that off since we don't need them now. So clean this, and shut it down like this. Okay, now so we're looking for the currents here. It's going to be easier if we find the total. In fact, we just have to find the total. Like we have to compress this resistance together to get a simpler circuit, something that will look like this eventually. Okay, so how to do that? We just start compressing. See that this and this are in parallel. These 3 and 4 ohms are in parallel. Why? Because they meet at 2 points, this point and this point, as I've shown here. So that's what we'll first condense, and that will give us a diagram like this. Just forget the details. I'm just going to draw other parts and how that will look like. Okay, give us something like this. Yes. So how do we add resistors in parallel? You multiply them and divide it by their sum. So 4 times 3 over 4 plus 3, that's 12 divided by 7, which will give us 1.7. Okay, so here this is 1.7. Notice that this 1.7 and this 6 ohms that's here are now in series, so we'll add them together. Remember, we're compressing, so our diagram will look something like this. Put it here. This is just a quick diagram, so it's not exquisite or anything. Now as we've done this, see again that this 2 ohms resistor and this, which we've not gotten the value, okay, that's 1.7 plus 6, because remember they are in series now, so just add them together. So 1.7 plus 6 will give us 7.7, which means this will be 7.7. okay, so this 7.7 and this 2 now, they meet at 2 points, which makes them parallel resistors now. So we use that same formula for parallel. Let me clean this off since we don't need it again. 7.7 times 2 over 7.7 plus 2, which is 9.7. That's going to give us 1.59. okay, so we're going to redraw this again to give us something like this. As I said at first, it's going to be a very simple circuit. So this is 1.59 and this is 1. Okay, so from here all we have to do is analyze the current division. Okay, current in series is the same thing, which means that the 5 amperes here will flow through 1.59 and the same thing will flow through 1. okay, and the same way we just condensed this whole resistor is the same way we'll break it back down to get the currents flowing through this 3 ohms resistor. So we'll start current divider rule. We're dividing 5 bar into the components of this 1.59. Remember that 1.59 is made up of this 2 here and this 7.7 here. Okay, so to divide 5 into that, we use CDR, that's current divider rule. 5 times 2, yeah, that's 10 divided by 9.7, that's 1.03. okay, so I can clean this off. Now we know that the current flowing through this 7.7 here is 1.03. okay, now remember that this 7.7 is now made up of 6 up here and 1.7 here. Current in series is the same. So 1.03 is flowing through 6, is also flowing to 1.7. Okay, so I can also clean this off. Done. So 1.03, right? Yeah, let me write that down. 1.03. Okay. Now what is left is this 3 and 4. Because remember, to get this 1.7, okay, I'm coming. To get this 1.7, we added this 3 ohm resistor and this 4 ohm resistor together. So we'll break it down again. Current divided rule. So to get current flowing to 3 ohm resistor, it's going to be total current that we're dividing by the other resistor over 4 plus 3, their sum, which is going to give us, calculate that, divided by 7, 0.59. Okay, and remember, as I stated in the first video, we have to note the direction because it's very important. Because once we consider each source, to get the final current flowing to this 3 ohm resistor, we're going to have to either add it up or subtract them from each other, depending on the direction that we get. So 0.59 in what direction? This 5 from here, we'll trace the current here. It's going down, it's going here, and it's coming to the left. So 0.59 to the left. Okay, so I'll clean everything and let me put it here. 0.59 to the left. Okay, now we've considered the first source, 2 more sources to go. Okay, so I'm going to draw back the original diagram. So let me clean the direction here because it might not be the same thing for this. Okay, so this was the initial diagram. So we've considered this already. Okay, so now let's consider this 7 here. Okay, so let's consider 7. We have to forget the other sources back, and to forget the other sources, what do? Let me do different ink for this one. We shut down voltage sources and open up current sources. So this 5 amperes, I'm just going to open it up, push, that's all. The diagram is just going to look like this for that part, and this, I'm going to close it down, meaning that I'm just going to draw a line through it like this. Ooh, I don't know if I like this color. So like this, right? And now I'm going to evaluate it. Let me use my blue. Okay, so again, as we did the first time, we'll condense it. Okay, 3 and 4 are still in parallel, right? Then what you should know is that since we're considering this 7 ohms resistor, okay, the current is flowing like this, but we don't even need that now. But yes, you do. Coming like this is going here, sure. But I want to show you that when it gets here, because there is nowhere for it to go once it reaches here, this current will not flow through this 1 ohm resistor at all. So we're just going to ignore this 1 ohm resistor, like completely ignore it, like cancel it out. Okay, that is why I'm going to ignore it. Okay, so just cancel it out like this and forget about it. So we'll start condensing. 3 and 4 are in parallel again. What did we do that time? That was 3 times 4 over 3 plus 4. We got something like 1.7. Yes, we got 1.7. Okay, so let me draw how the diagram will look like, so it'll be easier. So we'll have something like, we got 1.7 already, but so it's going to be something like this. Yeah, something like this. 1.7 here and 6 here. Note that this 1.7 and this 6 are now in series, but So what do? Again, we just add it. That's 7.7, which is very similar to what we got the first time. Same thing, in fact. So 7.7, 2, and for this is our final diagram, 2 and 7.7 again. Okay, so now we have to find the currents, right? Because we have voltage, we have total resistance going to be 9. That's 7.7 plus 2. Okay, so we can use normal formula: V equals to IR, I equals to V over R, and I is going to be equals to 9.7, which is, okay, no, V over R, right? That's V is 7. That's 7 over 9.7, which means that I is 0.72. Okay, since we have the currents flowing through this whole circuit, again, current in series is the same. So 0.72 that we got is flowing through 2 and also flowing through 7.7. Okay, so we'll have to break it down back again to get this 3 ohm resistor here. Okay, so we'll divide the 0.72 between the components that give us 7.7. That's 6 and 1.7. And again, current in series is the same now. So that's 0.72. It's still going to be the same thing that will flow through 6 and same thing that will flow through 1.7. So there's no division to actually go through. So let me clean this up. Keep in mind 0.72 is what we're dividing, right? Okay. So now, since we know 0.72 is what's flowing through this 1.7, 0 point, let me write it down. Okay. Then what makes up this 1.7? 3 and 4 here, right? So now we actually have to divide them because current in parallel is different. So that's when we use current divider rule. So to find the current flowing through the 3 ohm resistor, it's going to be the other resistor times the current that we're dividing over the sum of the total resistance. That's 4 plus 3, that's 7. So 4 times 0.72 divided by 7. And here I get I3 as 0.41. Then what direction? So we're starting from here, from this 7. Current is coming down because remember, in voltage, this short dash represents negative, long one represents positive, and it's always moving from negative to positive. So in voltage, so it's like this. Then it comes to the left. It's also going to go up here, right? But because there's a resistance here, right, what I take it as is that it's going to be slower than this part that is free. So I'm going to take it to the right. Okay, so the current here is going to be to the right. Let me clean all that up so you see the clear one. So it's going to be like this, right? Because this is slow. Then do not meet up here and here to now go up. So 0.41 to what? To the right. So again, I can clear up the screen. 0.41, right? And I can clean all these off. So let me write it down. We got 0.41 to the right. Okay. Now for the final source we're going to consider, it's going to be the one that was here. That's 9 volts. Okay. So we have already opened up the current source that was here. Now I'll just shut down this source here, right? That's by closing it. That's going to be something like this. Okay, and I'll draw this back as the 9 volts. Let me check the direction. Yes, 9 volts. Then we'll start the whole process for this one again. But here is not going to be how we did the first time because these two are no more parallel. So we'll start from here, the resistor for this to the source. So Yeah, so 2 and 6 are in series, right? They only meet at 1 point. So add them together, that's 8. So our diagram will look something like this is the 8 that we just got here, and this is 4, this is 3, and so on. So note that you see that this 8 and this 4 are in parallel again, because first of all they meet here and then they meet here. So we'll use the how to find total resistance in parallel. 8 times 4 over 8 plus 4, which is going to give us 8 times 4 divided by 12, 2.67. Okay, so the diagram from here is going to look something like this: 2.67 and 3. Okay, so let me clean this off. Right, so we already have this, and this was how the voltage source was, like this. So total resistance is going to be this plus this, okay, because they are in series, right? So 3 plus 2.67, that's 5.67. So we have V and we have R. So same thing we did in the previous calculation. I equals to V over R. We use this formula, which is going to be 9 over 5.67. So 9 over 5.67 gives us 1.59. That's 1.59. So the good part is that since 1.59 flows through these circuits, it's the same thing that flows through here that flow through here, remember, because they are series, right? So there's nothing, we don't have to break down this to get anything, because we already know that 1.59 flows through this 3 ohm resistor. Okay, so now what we have to do is find the direction, right? Remember, for voltage source, short one is negative, long one is positive, and it goes through the positive direction like this, going like this. Okay, so it's going to be 1.59 to the right. Okay, so note that in your mind, and let me clean everything else off. So clean everything else off. We'll do this, delete. Right, so now we have 1.59 to the right. So these 3 values that we've got, we'll add them together, right? So 1.59 goes to the right, so it's positive. 0.41 also goes to the right, so it's positive. But 0.59 goes to the left, so it is negative. So total currents flowing through the 3 ohm resistor is going to be 1.59 plus 0.41. That's 2 minus 0.59 minus 0.59. That's 1.41. So this is our final answer. The current flowing through the 3 ohm resistor is 1.41 amperes. Thank you for watching.